Okay, here are two for you guys to try out. So yeah, pause this video here, try them, then you will see us and we'll do them together. Okay, let's take a look at part A. First thing, we want to isolate our exponential. So we're going to add that 8 to the other side. 7 to the x plus 4 equals 200. Okay, then say, all right, I've got an exponential with base 7. So I want to take the log with base 7 of both sides. Log base 7 of 7 to the x plus 4 equals the log base 7 of 200. Why am I doing that? Well, because those base 7s cancel out and I get x plus 4 equals the log of 7, log of 200 base 7. And if I simply subtract the 4, I've got the exact answer. If I want the rounded answer, I'll use change of base formula, the natural log of 200 divided by the natural log of 7. Of course, you could use common log if you want. And then I'll grab my calculator. Natural log 200 divided by natural log 7 minus 4. Negative 1.2772 when I round it to 4 places. So there's my rounded answer for part A. Okay, part B. I think I'm going to need a new piece of paper. Let's try that out right here. All right. Hey, this time, we've got logarithms, so logarithmic equation. This time we're subtracting the problem that we did in the last video. We were adding. Well, the first thing we need to do is condense those into a single logarithm. How is that going to work? If we're subtracting, maybe you remember you divide your arguments. So it becomes a single log with base 2. That divided by that, 9x plus 50 over 2x plus 5, and it's still equal to 5. Okay. Then what? I've got a log base 2, so I'm going to put both sides in the power of 2. 2 raised to all of this over here, and 2 raised to the 5th. That whole thing up in the exponent of 2, and then 2 to the 5th. Okay, why do we do that? Because log base 2 and exponential base 2 cancel out. And I've got 9x plus 50 over 2x plus 5. That's equal to 2 to the 5th, which I'm pretty sure is 32. Let me check that. Yeah. Okay, so far so good. Now, if you made it this far, then I'm really impressed. Great job. You canceled out that logarithm. You found your way around having a log as part of the equation. But that leaves us here. And what do we do from this point? And oh man, yeah. Here's what we're going to do. We're going to multiply this denominator to the other side. We're going to multiply both sides by 2x plus 5. If I multiply both sides by that, they cancel out over here. And I've got 9x plus 50 equals 64x plus 160. And now that's going to be much easier to solve. Maybe I will subtract the 9x. They give me 55x. I'll subtract that 160. That's negative 110. Then when I divide by 55, negative 2 equals x. Okay, now when it comes to solving logarithmic equations, we have to be careful. It could be extraneous. Even if we just get one answer, it could be an extraneous solution. So we're going to take that negative 2 and go all the way back, plug it into our original. So let's see what happens when we do that. Do we get a true statement? Are there any problems? Here we are, plugging negative 2 back into the original problem. 9 times x, 2 times x, right? Okay, let's see what happens here. Well, that'd be negative 18. Negative 18 plus 50 is 32. Minus log. Negative 4 plus 5 is 1. Okay. Hey, what do you remember about the log of 1? 0. So that whole thing is gone, and we've got the log of 32 with base 2 equals 5. Is that really true? Well, we could find out. One way, if you remember this, we could rewrite it as x equals b to the y. All right, there's my y, my 2, my x. 32 equals 2 to the 5th. And yep, that's true. So x equals negative 2 does work out. That is the one solution here to part B. Okay, that does it for this chapter. I'll see you guys in the Zoom meeting. Good luck with homework.